Let's try solving this logarithmic equation together. Real quick, before we get started on solving the problem, if you'd like to download a free copy of this PDF, you can find a link in the description box below, as well as the annotated or answer key PDF as well. And besides that, feel free to pause the video if you'd like to try the problem on your own at any point, or just think about any of the steps or replay any of the parts that you need to listen to again. Let's get started. The equation we're going to solve here is log base 4 of the quantity of 2 to the x power plus 48 plus 1 is equal to x. Let's just start by rewriting the equation. Here's the original equation, and the first thing we're going to do is we're going to subtract both sides by 1 so that we can isolate the logarithm on the left side. Then we want to identify the base of the log, which in this case is going to be 4. Currently, we have this equation written in logarithmic form, but let's go ahead and rewrite this into exponential form. Remember, to rewrite this in exponential form, we take the base of the logarithm, which is going to be 4, we're going to raise it to the x minus 1 power, which is on the other side of the equation, and that will be equal to this 2 to the x power plus 48. So rewriting this equation in exponential form, we're going to write 4 to the x minus 1 power on the left side of the equation, and that's going to equal this 2 to the x power on the right side plus 48. At this point, notice that we have two different bases for our exponentials. We have a base of 4 and we have a base of 2. That's going to make this problem a little bit more complicated, so let's see if we can do some rearranging and make these the same base. Since 2 is a smaller base, let's see if we can rewrite 4 using base 2. Now remember that 4 can be rewritten as 2 to the second power since it's a perfect square, so we can rewrite this using base 2, which is what we're looking for. So let's go ahead and rewrite this using base 2. So 4 is 2 to the second power, and if we're going to multiply an exponent by an exponent, that's totally okay. So we're going to multiply this 2 times this x minus 1 quantity. Next, let's go ahead and distribute this 2 to the x and 2 to this negative 1. If we go ahead and do that, then we're going to have 2 as the base still, and then 2 times x is going to be the 2x power, and then 2 times negative 1 is going to be minus 2. So that whole exponent is going to be 2x minus 2. Then using another one of our exponent properties, we can go ahead and separate this into a product of two powers using the same base. So we can rewrite this as 2 to the 2x power multiplied by 2 to the, negative 2 power. And we could go backwards to check this if this makes sense, but multiplying something with base 2 and base 2 is still going to get you something with base 2. But then when you do that, you would add their exponents, so 2x plus negative 2 is equivalent or the same as 2x minus 2. Then we want to remember our negative exponent rules, so 2 to the negative second power is the same thing as 1 over 2 squared, or 1/4. So we can go ahead and rewrite this as 2 as our base, so we 2 to the 2x power, and we're going to multiply this by 1/4. And then finally, multiplying these two pieces back together, we can rewrite this as 2 to the 2x power in the numerator. And then since we're multiplying by 1/4, keep in mind that the same thing as dividing by 4. So this expression would be equivalent to what we started with. Now let's go ahead and just take this equivalent expression that we just found, that's base 2, so 2 to the 2x power over 4, and put that on the left side of the equation and set that equal to the right side, which we didn't do anything with yet. It's just going to be 2 to the x power plus 48. Then we're going to want to notice that the numerator on the left side actually looks pretty similar to this 2 to the x power on the right side, but they're a little bit different. There's an extra 2 there. But let's see if we can maybe manipulate this a little bit with some algebra. We can take this 2 to the 2x power and rewrite this as 2 to the 2 times x power, which is really the same thing. We're just going ahead and putting a multiplication sign in between them. Then keep in mind that because multiplication is commutative, we can change the order. We could also rewrite this as 2 to the x times 2 power instead, right? We can just change the order of the exponents. But finally, keep in mind that we can also rewrite this using a power of a power property. So we can write this as the quantity of this 2 to the x power, so the base of 2 raised to the x power, and this whole thing would be raised to the second power. So when you have this power to a power property, basically all you really do is you would end up multiplying these two exponents together, so you get 2 to the 2x power anyway, which is what we started with. Let's go ahead and substitute this back in for this 2 to the 2x power. Rewriting this, let's see what we're going to have here. On the left side, we're going to have this 2 as the base raised to the x power. Then that whole thing is going to be raised to the second power. This is all going to be on top of 4. And on the right side of the equation, we're going to have 2 raised to the x power, and then plus 48. At this point, it's really helpful to notice that we managed to get two of these 2 to the x powers in our expression. For a temporary substitution for the next few steps of this problem, let's go ahead and let u, or the variable u, represent this expression of this 2 to the x power. Making this u substitution and swapping out this 2 to the x power for u should make the next few steps of this algebra a little bit easier to do. So let's go ahead and take these 2 to the x powers that we have in our equation and then swap them out or substitute them with the letter u. Rewriting our equation with the substitution, we're going to get u squared over 4, and that's going to be equal to this u on the right side plus 48. Hopefully when you look at this equation, you notice that this is going to be a lot easier for us to solve and that it is a quadratic equation, right? So let's go ahead and clear out the fractions here. Let's start by multiplying both sides by 4, so at least we don't have to worry about any fractions. Multiplying everything by 4, the 4 is going to cross cancel on the left side, so we're just going to have u squared. That's going to be equal to 4 times u, so we're going to go ahead and write 4u right next to that. And then 48 times 4, I believe that's going to be 192. Now think back to what you've learned about quadratic equations. When you go ahead and solve them, you like them to be equal to 0. So let's go ahead and take this 4u and this 192 and subtract them from both sides of the equation to move them to the same side on the left side. So subtracting them from both sides, we're going to get u squared minus 4u. That's going to be what we have on the left side here, minus the 192, and that's going to equal 0. At this point, we have this quadratic equation written in standard form, and you could go ahead and solve it by using the quadratic formula. You could try completing the square, or we could hopefully factor this. I'm going to make a tree for 192 real quick. Alright, so we're looking for two factors that multiply to get to 192, but are going to be 4 apart from each other. So maybe I'll combine this 2, this 2, this 2, and this 2 together first. So 2 times 2 times 2 times 2, that would be 16. So that would be 16 from 4 of those 2's together. And let's see, 2 times 2 times 3. 2 times 2 is 4, 4 times 3 is 12. So 16 times 12 would be 192, and they are 4 away from each other. So I think those are my two factors I'm going to use here. Now, you might not always be able to get it on that first try, but this one seemed to work out pretty nicely here. Okay, so now we know our two factors. Let's go ahead and open up our two linear binomials. Let's go ahead and write these parentheses here and set it equal to 0. And so we know a is 1, so we're just going to have a 1u and a 1u in the beginning of these binomials. And then we're going to have a minus 16 and a plus 12 in them. Doesn't matter which one is which, just because a is equal to 1. Now our zero product property states that if one of these binomials is equal to 0, then the whole left side of the equation would equal 0. So if u minus 16, what would u have to be to make that 0? Well, u would have to equal 16. That would be one of our solutions. And what about this linear binomial? Well, u would have to equal negative 12, since negative 12 plus 12 is equal to 0 as well. Alright, so cool. We now know that u is equal to 16 and u is equal to negative 12. But what is u equal to? Remember, we made a substitution earlier. We said that u would be representing this 2 to the x power. So let's go ahead and substitute this 2 to the x power back in for u in both of these instances. Okay, so on our first scenario, let's go ahead and write u instead as 2 to the x power. And that's going to equal the 16 that we just found out. And then let's go ahead and take this second equation here. Instead of saying u, we're going to say 2 to the x power again, and this is going to equal negative 12. Alrighty, so for our equation on the left side here, instead of saying 2 to the x power is equal to 16, we could rewrite the 16 as base 2 as well. So we can rewrite that as 2 to the 4th power, right? And so if we know that 2 to the x power equals 2 to the 4th power, then we should be able to conclude here that x does equal 4. This would be one of our solutions. Alright, cool. So we got a solution from this equation on the left side. However, if we take a look at this equation on the right side, there is no value for x that we could come up with where 2 to that power would equal a negative value, right? So that's why exponential functions have a horizontal asymptote. And so for this one, we're going to say that there's not going to be a solution for this one. So we're just going to have this x equals 4 as our solution. Now that we got this solution, let's go ahead and check it to see if it is actually true. So let's see if x is actually equal to 4. So we're going to go ahead and rewrite this as log base 4, and that's going to be of this quantity of 2, and then we found out that x is 4. So let's hopefully see if this checks out for us. Plus 48 plus 1, And we're hoping that this is equal to 4 and that we're not going to have an extraneous solution or anything. If we did, that's okay too, but we do have to check just to make sure. Okay, let's go ahead and then just raise this 2 to the 4th power. That's going to be 16. And let's go ahead and add 16 plus this 48. So if we do 16 plus 48, that's going to be 64, I believe, right? So we have log base 4 of 64 on the left side of the equation, and then adding 1 to that, and hopefully that's going to equal this 4 on the right side of the equation. Then solving this logarithm, log base 4 of 64, that's asking how many 4s multiply together to get 64. Well, 4 times 4 times 4 is 64, so this would be equal to 3. So we can go ahead and say that 3 plus 1, that would equal this 4 on the right side. And since that is true, then we know that 4 does equal 4, and this checks out. So 4 is our solution, and it's not extraneous either, so we know we did a good job. So that wraps up this video on solving this logarithmic equation where we had to use some U substitution to make it look a little bit easier for us to solve, as well as use some quadratics as well involving some factoring. So hopefully you found this video helpful. If you did, please consider giving it a thumbs up. And as always, keep up the great work, and I'll see you in the next one.